Hello and a very soft welcome to the Whispered Lore. Settle in and let the sounds of the evening fade away. Tonight, we drift back through the centuries to the serene and misty lagoons of the Venetian Republic. Beneath the quiet lapping of the canals and the shimmering reflection of moonlight lies a story of profound ingenuity and deliberate rhythm. We will gently explore the immense logistical undertaking that gave the city its form, the slow, percussive work of driving millions of wooden piles deep into the mud. We will trace the meticulous, unending task of canal maintenance, ensuring the very lifeblood of the city could flow unimpeded through its arteries. So relax, close your eyes, and allow your mind to drift as we examine the foundations on water. The city of Venice presents itself to the modern observer, and indeed to the historical one, as a fundamental contradiction. It is a city of stone, of marble and brick, of immense weight and permanence, seemingly floating upon the shifting, transient surface of water. This visual and structural paradox is the central inquiry of our study. It is an urban space that should not, by the conventional logic of civil engineering, exist in its current form, in its chosen location. Yet it does. It has endured for over a millennium, a testament not to a defiance of nature, but to an intimate, laborious, and ceaselessly negotiated understanding of it. This is the story of its foundations, both literal and logistical, an exploration of the immense, hidden enterprise that supports the impossible city. To comprehend the Venetian achievement, one must first comprehend the Venetian lagoon. It is not the open sea. It is a distinct and complex ecosystem, a shallow, enclosed bay of the Adriatic, stretching approximately 50 kilometers from north to south and 11 kilometers across. Its very existence is a delicate balance, protected from the open sea by a thin chain of barrier islands, or lidi, and fed by the freshwater and sediment of several rivers, most notably the Brenta and the Piave, whose mouths were systematically diverted by the Venetian Republic over centuries to prevent the lagoon from silting into a marshland. The water within is brackish, its depth variable, and its bottom a composite of unstable materials. Beneath the placid surface lies a layered stratigraphy of sand, silt, and soft alluvial clay, a viscous, uncooperative medium offering no natural purchase for heavy construction. These layers of soft sediment can extend downwards for many meters, a legacy of millennia of river deposition. Only far below this yielding mud does one find a layer of significantly more compressed clay and sand, a stratum known as the Caranto, which possesses the load-bearing capacity necessary for a stable foundation. The challenge, then, for the early settlers of the lagoon was not simply to build on wetlands, but to bypass the initial meters of unstable geology entirely and anchor their city to the firmer substrate hidden deep below the lagoon floor. The impetus for this extraordinary undertaking was not ambition, but desperation. The decline of the Roman Empire in the 5th and 6th centuries unleashed successive waves of invasions across the Italian peninsula. Mainland populations from cities such as Padua, Aquilea, and Altinum fled the incursions of the Goths, the Huns, and later the Lombards. They sought refuge in the least hospitable, yet most defensible, terrain available, the scattered, marshy islands of the lagoon. This shallow, labyrinthine body of water, with its hidden channels and treacherous mudflats, was an impassable barrier for land-based armies and their cavalry. The lagoon was a moat provided by nature, and survival was the sole motivation for learning to inhabit it. The initial settlements were modest, comprised of wood and wattle and daub, lightweight structures suitable for the marshy ground. But as the community grew in wealth and power, coalescing into the Republic of Venice, its architectural aspirations evolved. The desire for permanent, monumental structures of stone, churches, palaces, bell towers, posed a direct confrontation with the fundamental instability of the ground. The solution they devised was as audacious as it was laborious, and it began with wood, an immense quantity of wood. The foundation of a typical Venetian building is not a solid mass resting on the mud, but rather a dense forest of wooden piles, driven deep into the lagoon bed. These piles, sharpened at one end, were primarily made of alder, a wood known for its exceptional resistance to rot when fully submerged in an anaerobic or oxygen-poor environment. The image of Venice, as it exists in the collective consciousness, is one of permanence, a city of stone and water, seemingly eternal, suspended between the tides. Yet, this perception of solidity is a profound illusion, a triumph of human ingenuity over an inherently unstable environment. To understand the foundations of the Venetian Republic, one must first understand that Venice was not founded in the conventional sense. It was not planned, nor was it conquered. It was, rather, an accretion, a slow, centuries-long process of retreat and adaptation, born from the collapse of a world order. Our story begins not in the shimmering lagoon, but on the mainland, the terra firma, in the waning light of the Western Roman Empire. The plains of what are now the Veneto and Friuli regions were, in the 4th and early 5th centuries, a prosperous and well-ordered part of the Roman world. Cities like Acque, a major administrative and commercial hub, Patavium, now known as Padua, Altinum, and Concordia Sagittaria, were nodes in a network of roads, aqueducts, and agricultural estates. Life was predicated on the stability of the land and the security provided by the Roman state. This stability, however, was a fragile construct. Beginning in the early 5th century, this world began to systematically unravel. The initial tremors were felt with the incursions of the Visigoths under Alaric, culminating in the sack of Rome in the year 410. While the direct impact on the northern provinces was significant, it was the subsequent waves of migration and invasion that proved existentially transformative for the region's inhabitants. The critical event, the one most often cited in the foundational narrative of Venice, was the arrival of the Huns under Attila in the year 452. The Huns were not interested in assimilation or governance. Their methodology was one of total destruction. They swept into the plains, and the great Roman cities, built for commerce and administration, not for protracted siege warfare against such a force, fell one by one. Acque was razed so thoroughly that its precise location was debated for centuries. Altinum and Concordia were similarly obliterated. The inhabitants of these urban centers, the Veneti, faced a stark choice: subjugation and death, or flight. They fled. Their destination was dictated not by choice, but by geography and the nature of their persecutors. The invaders were a land-based power, their strength rooted in cavalry and infantry. The one sanctuary they could not easily reach lay just off the coast, the Venetian lagoon. This was not a welcoming paradise. The lagoon, or lacuna in Latin, was a vast, semi-enclosed coastal bay, approximately 50 kilometers long and between 8 and 14 kilometers wide. It was a liminal space, neither truly land nor truly sea. A complex ecosystem of salt marshes, mudflats, and a constellation of over 100 small, low-lying islands. Let us consider the specific topology of this environment. It was separated from the Adriatic Sea by a thin barrier of littoral islands, the laidi. These sandbars were breached in only a few places, the porti, or inlets, which allowed the tide to flood and ebb twice daily. This constant tidal action was crucial. It prevented the lagoon from silting up completely and becoming a freshwater swamp, yet it also created a treacherous, ever-shifting network of navigable channels. The majority of the lagoon was composed of extremely shallow water, mudflats, or the barrene, sections of salt marsh vegetated by hardy, salt-tolerant plants, which were submerged only during the highest tides. To an outsider, particularly an invading army, it was an impassable maze. The shallow depths would ground any vessel of significant draft, while the soft, yielding mud would mire horses and soldiers. For the refugees from the mainland, however, this hostile environment was the very source of their security. To comprehend the foundations of Venice, one must first comprehend the absence of foundation. The city, a testament to human ingenuity and persistence, does not rise from solid earth. It floats, suspended upon a framework of human design, anchored in a substrate that is itself a product of constant, subtle, geological flux. This chapter is an examination of that substrate, the unstable ground that presented the Venetian Republic with its most fundamental and enduring challenge. The story of Venice is not written on stone, but on water, mud, and time. The Venetian lagoon is a geological feature of relative youth. It is a transitional environment, a liminal space between the continental landmass of the Po Valley and the marine expanse of the Adriatic Sea. Its existence is a direct consequence of the end of the most recent glacial period, the Worm Glaciation, which concluded approximately 11 to 12,000 years ago. During that epoch, vast quantities of the Earth's water were locked in continental ice sheets, causing global sea levels to be substantially lower than they are today. The northern Adriatic was not a sea, but a wide, exposed alluvial plain, crossed by the ancestors of the Po, Adige, Brenta, and Piave rivers. As the global climate warmed and the ice sheets retreated, this stored water was released, initiating a period of marine transgression. The sea level rose steadily and inexorably, advancing across the low-lying coastal plain. This gradual inundation flooded the river valleys, transforming them into a complex system of estuaries and salt marshes. The Venetian lagoon is a remnant of this ancient coastal system, a semi-enclosed body of brackish water protected from the open sea by a series of barrier islands, or lidi. The character of the Venetian substrate is defined by an almost total absence of solid rock. This condition is the result of millennia of alluvial deposition by the rivers that once flowed freely into the lagoon. These rivers, carrying fine-grained sediments eroded from the Alps, slowed dramatically as they met the quiescent waters of the lagoon. As their velocity decreased, their capacity to transport sediment diminished, and they deposited their load across the lagoon floor. This process, occurring over thousands of years, built up a deep and complex sequence of unconsolidated materials. To understand the challenge faced by the first Venetian builders, we must examine the stratigraphy of this subsoil, the vertical sequence of its layers. A core sample drilled anywhere beneath the city reveals a history of changing environmental conditions. The uppermost layer, extending down for several meters, consists of very recent deposits. This is a soft, dark, organic-rich silt, known locally as limo. It is composed of fine clay and silt particles, mixed with decomposed biological matter from the lagoon's ecosystem. This material has an extremely high water content and virtually no cohesive strength. It is, in engineering terms, a slurry. It cannot support any significant load. A stone dropped onto its surface would simply sink. Below this superficial layer of soft mud, one typically encounters a sequence of interbedded silty clays and fine sands. These layers represent the shifting patterns of river deltas and tidal channels over centuries. A layer of sand might indicate a period when a river channel or a strong tidal current passed over the area, depositing coarser material. A layer of clay indicates a calmer period, allowing the finest particles to settle out of suspension in still water. These layers are more compacted than the surface mud, but they remain soft and highly compressible. Their load-bearing capacity is minimal and, crucially, unpredictable. The thickness and consistency of these layers varies significantly over very short distances, making any attempt at conventional shallow foundation construction a near impossibility. The visible city of Venice, a delicate filigree of stone, marble, and brick, rests upon an invisible one. This submerged city is not built of enduring mineral, but of organic, perishable material, a vast, petrified forest of wood. The millions of timber piles, driven deep into the unstable silt of the lagoon, form the true bedrock of the Republic. They are the silent, unseen guarantors of its existence. To understand the foundations of Venice is, therefore, to understand the monumental, centuries-long logistical operation that supplied this foundational material. This was the timber lifeline, a complex network of arteries that channeled the lifeblood of mainland forests into the heart of the lagoon city. The story of sourcing these forests is not one of conquest or rapid exploitation, but one of meticulous, bureaucratic, and far-sighted administration. The Venetian state, born of necessity and pragmatism, recognized early in its history that its survival was intrinsically linked to its control over timber. Lacking any significant forests of its own on the sandy liddy of the lagoon, the Republic turned its gaze inward, toward the mainland territories it progressively acquired from the 14th century onwards, the domain known as the terra firma. This expansion was not merely for agriculture or strategic depth. It was a conscious and deliberate campaign to secure the Republic's most vital strategic resource. The mountains of the Dolomites, the foothills of the Alps, and the dense woodlands of Istria and Dalmatia became, in effect, extensions of the Venetian arsenal itself. The management of this vast green patrimony was not left to chance or the whims of local lords. The Venetian government, with its characteristic penchant for regulation and oversight, established a dedicated magistracy, the Provveditori ai Boschi, the supervisors of the woods. This powerful office, instituted formally in the 16th century but with roots in earlier ad hoc committees, was tasked with the systematic administration of every significant forest under Venetian dominion. Their mandate was all-encompassing. They were to survey, map, and classify the woodlands, creating detailed inventories of the available timber. They designated certain forests as state property, the Bosco della Serenissima, reserving their output exclusively for the needs of the city and its navy. The Provveditori issued strict edicts governing the felling of trees. Unauthorized cutting was met with severe penalties, including fines, imprisonment, and even galley slavery. They specified which species of tree were to be used for which purpose, a testament to the Venetians' profound and practical understanding of dendrology. Oak or rover, especially the hard, durable variety from the Istrian Peninsula, was prized for the curved frames and planking of warships. The tall, straight silver firs, abezo and larch, laris, from the high valleys of the Cadore and Belluno, were reserved for the masts and spars of the fleet. Beech, or faggio, from the Cansiglio forest, was deemed ideal for the long oars, the remi, that propelled the Republic's galleys. And for the critical task of foundations, the piles, or pali, the preferred species were alder, ontano, and larch. Alder, in particular, was highly valued for its remarkable ability to resist rot when permanently submerged in water, a process of petrification that rendered it almost as hard as stone over time. The process of sourcing began not with the swing of an axe, but with the careful eye of a Venetian agent. Specialized officials, known as marcafucci, would journey deep into the mountain valleys. These men were expert assessors of timber, capable of judging the quality, height, and straightness of a tree at a glance. They would select individual trees suitable for the state's purposes, whether for a galley's keel or a palace's foundation. We now turn our attention from the canals that form the arteries of Venice to the complex that was its industrial heart. Here, within a secluded and heavily guarded sector of the city, lay the Arsenale. It was not merely a shipyard, but a vast, integrated ecosystem of production, storage, and innovation that underpinned the maritime power of the Venetian Republic for centuries. To understand the Arsenale is to understand the material basis of Venetian dominance, a preeminent industrial enterprise of the pre-industrial world, a place where the logistics of naval power were refined to an unprecedented degree of efficiency. The origins of the Arsenale are rooted in the practical necessities of a burgeoning maritime state. The initial core, known as the Arsenale Vecchio, or Old Arsenal, is believed to have been established in the early 12th century, around the year 1104. This first enclosure provided a secure, state-controlled space where the Republic's warships could be constructed and maintained, away from the private shipyards, or squarey that built the city's merchant vessels. It consisted of a single basin, a darsena, surrounded by workshops and slipways. This consolidation of naval construction was a critical step, centralizing skills and resources under the direct authority of the state. As Venice's commercial and military ambitions expanded throughout the Mediterranean, so too did the need for a larger and more capable fleet. This led to the first major expansion of the complex in the early 14th century. The construction of the Arsenale Nuovo, the new arsenal, beginning around 1325, more than doubled the size of the facility. A new, much larger basin was excavated, and the surrounding land was developed to accommodate more workshops, forges, and most importantly, covered slipways. This expansion was a direct response to the increasing scale of naval warfare and the need to produce larger galleys in greater numbers. The entire complex is enclosed by a high, crenellated wall of red brick, stretching for nearly 2 miles. This wall served not only for defense, but also for secrecy, isolating the critical technologies and production methods from prying eyes. Access was strictly controlled through a limited number of gates. The primary entrance from the land, the Porta Magna, or Great Gate, was constructed around 1460. It stands as the first example of Renaissance Revival architecture in Venice, a triumphal arch flanked by lions, one of which was brought from the Greek port of Piraeus. This grand entrance was more than a mere gate. It was a statement of the Republic's power and the immense importance of the work conducted within. Inside these walls, the layout was a model of logistical planning. The dominant features are the basins, the large bodies of protected water where ships were launched and fitted out. Radiating from these basins were the slipways and workshops. The most characteristic buildings are the tees, the long, roofed sheds where the hulls of the galleys were constructed. These long, narrow buildings, with their distinctive timber trussed roofs supported by columns of brick or stone, were aligned perpendicular to the water's edge. This design allowed a ship's hull, once constructed, to be launched directly into the adjacent canal or basin. The foundations for these massive structures, like all of Venice, relied on timber piling. Given the immense weight of the brick walls, the timber roofs, and the galleys themselves, the ground beneath the tees had to be meticulously prepared. Thousands of short, sturdy piles of alder or oak were driven deep into the soft sediment until they reached the resistant layer of compressed clay known as the coranto. Upon this dense forest of underwater piles, a stone platform, or zadoran, was built, providing a stable base for the construction above. The slipways themselves were often paved with stone, angled gently towards the water. The city of Venice, a testament to human ingenuity, rests upon an illusion. It appears to float on the shimmering surface of the lagoon, a collection of stone and marble tethered to the water itself. But the reality is far more terrestrial, far more deeply rooted. Beneath the palazzos and piazze, a hidden forest exists. A vast, unseen network of millions of wooden piles, driven deep into the soft sediment of the Venetian lagoon, provides the very foundation upon which the city stands. For centuries, these wooden stilts have borne the immense weight of the Republic, resisting the constant assault of water, salt, and time. The enduring question, one that has puzzled engineers and historians alike, is simple. How does wood, a perishable organic material, survive for centuries in such a hostile, aquatic environment? The common, almost mythic, answer is that the piles have turned to stone, that they have undergone a process of petrification. This chapter will explore the nuanced and complex science behind this remarkable endurance, separating folkloric explanation from a fascinating reality governed by chemistry, biology, and the unique geology of the Venetian substrate. The term petrification, while evocative, is a geological misnomer in this context. True petrification, or permineralization, is a fossilization process that occurs over millions of years. It involves the slow, molecule-by-molecule replacement of organic material with minerals as groundwater saturated with silica, calcite, or pyrite percolates through buried remains. What happens to the Venetian piles is a different, though equally remarkable phenomenon, a state of arrested decay supplemented by a slow, external mineralization. The longevity of the piles is not the result of a single magical transformation, but rather a precise confluence of carefully selected materials and specific, stable environmental conditions. The primary and most critical factor in the preservation of these wooden foundations is the absence of oxygen. Wood decay is not a simple process of dissolution in water. It is an active biological process, driven primarily by microorganisms, specifically fungi and bacteria. These decomposers, like most complex life, are aerobic. They require oxygen to metabolize their food source. In this case, the structural components of the wood, namely cellulose and lignin. The Venetian founders, through centuries of trial and error, understood this principle implicitly. The piles, typically made of alder, larch, or oak, were not merely placed in the water. They were driven with immense force, hammered deep through the layers of soft silt and sand, until they reached a layer of dense, compressed clay known as the Coranto. This Coranto layer is the key to the entire system. It is a stratum of extremely compact, blue-gray clay, so dense that it is almost impermeable to water and, crucially, to oxygen. Once a wooden pile is driven into this anoxic or oxygen-free substrate, it is effectively sealed off from the primary agent of its own destruction. The base of the pile, which bears the most significant load, is entombed in a stable, sterile environment. The microorganisms responsible for rot, which thrive in damp, oxygen-rich environments, simply cannot survive here. Their biological machinery, which relies on oxidative processes to break down the complex lignocellulosic polymers of the wood cell walls, is completely shut down. The wood, therefore, exists in a state of suspended animation. It is saturated with water, but the biological agents that would normally use that water to facilitate decay are entirely absent. The portion of the pile above the Coranto layer, submerged in the mud and silt of the lagoon bed, also benefits from a severely oxygen-depleted environment. The dense, waterlogged sediment of the canal floors contains very little free oxygen. In the quiet, aqueous theater of the Venetian lagoon, where solid ground is a negotiated concept rather than a given, the creation of the city's foundations was an act of profound and repetitive labor. Before the first stone of a palazzo could be laid, before the arch of a bridge could be conceived, the unstable silt and mud of the seabed had to be conquered. This conquest was not achieved by grand, singular gestures, but by the patient, rhythmic, and relentless driving of thousands upon thousands of wooden piles. At the heart of this foundational effort was a machine, a towering wooden structure that, for centuries, defined the soundscape of Venetian construction. It was known as the Battipalo. The term Battipalo translates simply to pile beater or pile driver, a name that belies the intricate synthesis of human and mechanical effort it represented. It was not an automated engine in any modern sense. It was, rather, a human-powered amplifier of force, a skeletal giant of wood and rope whose heart was a chorus of men, and whose purpose was to lend their collective strength to the singular percussive task of driving timber deep into the unseen earth below the water. To understand the Battipalo, one must first visualize its form, a form dictated entirely by function and the simple laws of physics. The primary structure was the castello, or castle, a tall vertical frame typically constructed from sturdy larch or oak beams. This frame, often triangular in its profile for stability, could reach heights of 10 to 15 meters. It was a stark, unadorned scaffold, its timbers weathered by sun and salt spray. The entire apparatus was mounted upon a broad, flat-bottomed raft, or zattera, which allowed the machine to be floated to any point in the canals or the open lagoon where new construction was to take place. This mobility was crucial, transforming the waterways themselves into the primary avenues for the city's own expansion. The operational core of the Battipalo was the maglio, the great hammer or mallet. This was a massive block of dense wood, typically elm for its resistance to splitting, though sometimes oak was used. It was often bound with heavy iron straps, both to add weight and to prevent the wood from fracturing under the immense and repeated stress of impact. The weight of the maglio varied, but it could range from 200 kilograms to well over a ton, depending on the scale of the machine and the nature of the piles to be driven. This was the instrument of persuasion, the object through which the combined energy of many men would be focused onto a single point. The maglio was guided in its vertical travel by two parallel rails integrated into the castello. These guides ensured that the hammer would fall true, striking the head of the pile squarely and without deviation. The process of raising this immense weight was accomplished through a system of ropes and pulleys. The main ropes, or canopi, were thick, hand-woven hemp cables, materials chosen for their strength and relative flexibility. These ropes would pass through a series of pulley blocks, known as the taglia, fixed at the apex of the castello. The use of pulleys provided a mechanical advantage, reducing the individual force required from each man, but it did not reduce the total work to be done. It merely distributed the load, allowing a team of men to achieve what would be impossible for any individual. The human engine itself was a team of laborers, the battipali or tiratori, the pullers. The size of this team could vary significantly, from as few as 20 to as many as 50 or 60 men, again depending on the weight of the maglio. These men would stand on the deck of the zattera or on an adjacent work platform, each man grasping one of the numerous rope ends that cascaded down from the pulley system. They were the source of all motive power, the living components in a machine of wood and iron. The Rialto Bridge, as it stands today, is an icon of Venetian architecture, a single, elegant stone arch spanning the Grand Canal. Its form is familiar, its function self-evident, but the narrative of its visible superstructure, of the shops that line its ascent and the crowds that cross its apex, often obscures the more fundamental story. This is the story of its foundation, an immense and meticulously engineered structure, hidden beneath the murky waters of the canal. The raising of the Rialto Bridge between 1588 and 1591 was not primarily a challenge of stone masonry, but a profound exercise in hydrological engineering and logistical planning. It is a case study in the Venetian mastery of creating stability where nature offers none. The preceding structure, a wooden bridge with a central drawbridge section, had served Venice for centuries, but its timber construction was subject to the inevitable cycles of decay and the perennial risk of fire. By the latter half of the 16th century, its structural integrity was compromised, and the decision was made to replace it with a permanent stone edifice. The design competition attracted proposals from the most eminent architects of the age, including Michelangelo and Palladio, many of whom favored a classical multi-arch design. However, the winning proposal, by the aptly named Antonio da Ponte, presented a radical and audacious solution, a single span. This design, while aesthetically bold, placed an unprecedented engineering burden on its two terminal points. All the immense compressive forces of the stone arch, weighing thousands of tons, would have to be borne by two abutments constructed on the notoriously unstable silty banks of the Grand Canal. The fundamental challenge, therefore, was not merely one of spanning the 48-meter-wide canal, a significant feat in itself, but rather one of establishing two immovable points of purchase within a substrate that offered little in the way of natural stability. The geology of the Venetian lagoon is composed of successive layers of soft clay, sand, and alluvial silt, deposited over millennia. The first truly stable layer, a compressed clay known as the Caronto, lies many meters below the canal bed. Reaching it was impractical. The Venetian solution, refined over centuries of construction, did not rely on reaching a solid base, but on creating one. This was to be achieved through the strategic use of timber piles. The first operational phase involved isolating the construction sites on each bank from the canal itself. This required the construction of massive cofferdams. These were not simple fences, but complex, double-walled structures. On each bank, a perimeter extending well into the canal was delineated. Along this line, thousands of large piles were driven deep into the canal bed. These primary piles formed the retaining walls of the cofferdam. They were driven close together, their edges nearly touching, to form a palisade. A second, parallel palisade was constructed inside the first, with a gap of approximately 1.5 meters between the two walls. This interstitial space was the key to the cofferdam's impermeability. It was methodically filled with high-quality clay, sourced from the mainland and transported to the site by barge. Workers packed the clay into the gap, tamping it down layer by layer to create a dense, watertight seal. This process was slow, laborious, and critical. Any significant leak would compromise the entire operation. Once the cofferdams were sealed, the process of dewatering began. Using Archimedean screws and teams of laborers with buckets, the water within the enclosed area was laboriously removed. As the water level dropped, the immense hydrostatic pressure of the Grand Canal pressed against the outer walls of the cofferdam, testing the integrity of the pile walls and the clay seal. The structure had to be braced from within to resist this force. The Venetian Republic, in the year 1630, found itself in the grip of a devastating outbreak of bubonic plague. It was an existential crisis that brought the city to its knees. In a desperate plea for divine intercession, the Senate of the Republic made a solemn vow. If the city were delivered from the pestilence, they would erect a magnificent temple in honor of the Virgin Mary, a church to be known as Santa Maria della Salute, Saint Mary of Health. By 1631, the plague had receded, and the Republic, true to its word, prepared to undertake one of the most ambitious construction projects in its history. The chosen site was a prominent yet profoundly unstable point of land at the entrance to the Grand Canal, the Punta della Dogana. Here, the architectural vision of Baldassare Longhena would rise, a colossal octagonal structure crowned by a soaring dome. But before the first block of Istrian stone could be laid, a far more fundamental challenge had to be met: the creation of a foundation capable of supporting such an immense weight on the soft, waterlogged silt of the lagoon. The solution, while traditional in its concept, was staggering in its scale. The foundation of the salute would rest upon a man-made forest, a dense, subterranean woodland of more than 1 million timber piles. This case study examines the intricate logistical and engineering processes required to procure, transport, and install the immense number of piles that form the unseen support for the Basilica di Santa Maria della Salute. It is a testament to the Venetian Republic's mastery of hydraulic engineering, its organizational capacity, and its deep understanding of the unique geotechnical properties of its environment. The primary challenge was and remains the geology of the Venetian lagoon. The ground beneath the city is not solid earth. It is a complex stratigraphy of unconsolidated materials deposited over millennia by the region's rivers. The uppermost layers consist of soft silt, sand, and clay, offering very little compressive strength. Deeper down, typically between 5 and 10 meters, lies a more compacted layer of dense clay and sand known as the Coranto. This layer, while not bedrock, is significantly more stable and capable of bearing substantial loads. The fundamental principle of Venetian foundation engineering was to bypass the weak upper layers and transfer the structural load of a building directly to this competent Coranto stratum. This was achieved through the use of timber friction piles. The piles function in two ways. First, as point-bearing elements, their tips resting on or penetrating into the Coranto layer. Second, and perhaps more importantly in this specific context, they function through skin friction, where the combined friction between the surface of the thousands of piles and the surrounding compacted soil creates a stable, unified mass that resists subsidence. The first logistical hurdle was the procurement of the timber itself. The specifications were exacting. The piles needed to be long, straight, and made from wood that could withstand permanent immersion in the anaerobic saline mud of the lagoon. The ideal timbers were larch and alder, woods rich in resins that offered natural resistance to decay. Oak was also used, particularly for the horizontal platforms that would be laid atop the driven piles due to its immense strength. The Venetian Republic, in its foresight, had established control over vast tracts of forest on its mainland territories, the terra firma. The forests of the Cadore region, in the foothills of the Dolomites, and the forests of Istria, across the Adriatic, were the primary sources. The process began with the felling of an enormous number of trees. Records suggest the piles for the salute were typically between 4 and 8 meters in length. Each log was carefully selected, felled, and stripped of its bark and branches. This work was carried out by specialized teams of woodsmen. The Venetian Republic, an entity seemingly conjured from the mists of the Adriatic, owes its very existence not to solid ground, but to a complex and intimate relationship with water. This relationship is most profoundly expressed in its circulatory system, the intricate and ever-present network of canals. These are not merely channels for transport. They are the city's streets, its foundations, its lifeblood. To understand Venice is to understand the constant, quiet, and monumental effort required to maintain these aqueous arteries. The origins of the canal network lie not in human design, but in the natural hydrography of the lagoon itself. Before the first settlers sought refuge on the marshy islands, the lagoon was a sprawling ecosystem of deeper navigable channels, shallow tidal flats known as velm, and salt marshes called barrene. The early Venetians did not impose a grid upon this landscape, but rather adapted to it, reinforcing the banks of the existing natural channels, gradually defining their courses, and connecting them to form a cohesive system. The Grand Canal, the city's majestic central thoroughfare, follows the sinuous path of an ancient riverbed, a testament to this process of adaptation rather than imposition. The hierarchy of this network is precise. The primary artery is the Canal Grande, a sweeping reverse S-curve that divides the city into two unequal parts. Branching from it are the canali, the larger secondary waterways, wide enough to accommodate significant traffic. From these, in turn, extends a capillary system of smaller canals, known as rii, the plural of Rio. It is these rii that penetrate the deepest recesses of the city's 6 districts, or sestieri, reaching every parish and nearly every doorstep. A further distinction exists between a Rio Interno, a canal that flows within the confines of a single island, and a Rio Esterno, which serves as a boundary between 2 or more separate islands. Over centuries, some of these smaller rii were deemed superfluous or problematic for public health, and were filled in to create pedestrian streets, a process that gave rise to the term Rio Terra, or, quote, earthed canal, a name that survives in the city's topography today. The functionality of this entire system depends on a single, powerful, natural engine, the tide. Twice each day, the Adriatic Sea breathes into the lagoon through the 3 inlets at Lido, Malamocco, and Chioggia. This influx of water, a phenomenon known as the acqua alta in its extreme form, raises the level of the canals, and its subsequent retreat, the ebb tide, draws the water back out. This diurnal flushing was, for centuries, the city's only sanitation system. It carried away waste and debris, preventing stagnation and the proliferation of disease that would have otherwise made life in such a densely populated, waterlogged environment untenable. The very survival of the Republic was predicated on the unimpeded flow of this tidal exchange. However, the same tides that cleansed the city also posed its greatest existential threat through the inexorable process of sedimentation. The rivers that once emptied freely into the lagoon carried vast quantities of silt, while the sea itself brought in sand and mud. This material, suspended in the tidal flow, would gradually settle in the slower-moving sections of the canals, raising the canal bed, impeding navigation, and threatening to choke the city's arteries. Without constant intervention, the canals of Venice would have silted up and transformed into stagnant, impassable mud channels within a matter of decades. The Venetian Republic, ever pragmatic, established a powerful and highly specialized government body to combat this threat, the Magistrato alle Acque, or the Magistracy of the Waters. This institution, established in the early 16th century, held immense authority over every aspect of the lagoon's hydrology. The survival of Venice, a city built upon the shifting sands and mutable tides of a coastal lagoon, was never a matter of chance. It was, from its earliest days, an act of continuous, deliberate, and meticulous engineering. The serene surfaces of its canals, reflecting the palatial facades, belie a constant, underlying struggle against the forces of nature, the silting of waterways, the erosion of islands, the inexorable pull of the sea. To manage this precarious existence, the Venetian Republic, in its characteristic fashion, did not rely on intermittent efforts or temporary committees. It created a permanent, powerful, and deeply bureaucratic institution, a magistracy whose singular focus was the water itself. This was the Magistrato alle Acque, the magistrates to the waters, the ultimate guardians of the lagoon and the hydrological foundation upon which the entire edifice of the Serenissima rested. The formal establishment of the Magistrato alle Acque in 1501 was not a sudden innovation, but rather the culmination of centuries of evolving water management practices. From the 13th century onwards, various commissions, often with overlapping and ill-defined jurisdictions, were appointed to address specific hydraulic crises. Offices such as the Savi alle Acque, or Sages of the Waters, and the Provveditori al Sal, who managed the state salt monopoly and thus had a vested interest in the lagoon's salinity, tackled problems as they arose. However, the recognition grew that the lagoon was a single, interconnected system. An intervention in one area, such as the dredging of a channel near the Lido Inlet, could have unforeseen consequences for the flow of water in the canals of the city center, or the health of the salt marshes near Chioggia. The piecemeal approach was insufficient. What was required was a holistic, unified authority, with the power to plan and execute long-term strategies, overriding private interests and even the jurisdictions of other civic bodies for the greater good of the Republic's survival. Thus, the Magistrato alle Acque was created, consolidating the powers of its predecessors into a single, formidable entity. Its composition reflected the gravity of its mission. The board was typically led by a council of high-ranking patricians, often seasoned senators and former diplomats, men whose careers had trained them in the arts of long-term planning and complex administration. These were the provveditori, the overseers, who set policy and approved major projects. Beneath them served the secutori, the executors, who were responsible for the day-to-day implementation of the board's decisions. The true strength of the institution, however, lay in its technical staff. The Magistrato employed a permanent corps of engineers, known as proto, architects, and hydrographic surveyors, or periti. These were men of immense practical knowledge, often from families who had served the Magistrato for generations. They possessed an intimate, almost hereditary understanding of the lagoon's currents, shoals, and sedimentary patterns. Their work was supported by a legion of scribes, notaries, and accountants, who meticulously documented every survey, every contract, every expenditure, creating an archive of unparalleled detail on the lifeblood of the city. This archive was not merely a record. It was a living tool, consulted daily to inform future decisions and understand the slow, long-term evolution of the aquatic environment. The jurisdiction of the Magistrato alle Acque was vast, extending far beyond the canals of the city proper. Its primary and most encompassing mandate was the preservation of the lagoon's delicate hydrographic equilibrium. This meant ensuring a sufficient exchange of water with the Adriatic Sea through the three main inlets, or porti, the Lido, Malamocco, and Chioggia. A healthy tidal flow was essential. The existence of Venice is a testament to a continuous negotiation with water. While the driven piles provide a static foundation, the canals, the city's arteries, demand a dynamic and unceasing form of maintenance. This is the realm of dredging, a task less of construction and more of perpetual curation, an endless effort to counteract the lagoon's fundamental tendency to return to marshland. The process is not one of dramatic engineering, but of slow, methodical, and profoundly laborious removal. It is the art and logistics of subtraction. The primary antagonist in this silent, ongoing conflict is sediment. Known locally as fanghelia, this accumulation is a complex mixture. It consists of alluvial silt, carried into the lagoon by the rivers Brenta and Alle, fine sand swept in from the Adriatic Sea by the biannual tides, and the organic and inorganic detritus of a densely populated city. Every fallen leaf, every discarded fragment, every particle of eroded brick from a canal side wall eventually settles on the canal bed. Over time, this soft, dense layer of mud accretes, imperceptibly at first, then with profound consequences. A canal, or rio, that is allowed to shallow becomes sluggish. The vital tidal flushing, the aqua morta and aqua viva that twice a day cleanses the city's waterways, is impeded. Stagnation follows, bringing with it unsanitary conditions and foul odors. More critically, for a mercantile republic, a shallow canal becomes unnavigable for the flat-bottomed cargo barges, the peat, that were the lifeblood of Venetian commerce. Gondolas and smaller craft might still pass, but the transport of stone, timber, wine, and grain would grind to a halt. The city's very metabolism would be threatened by this slow, silent choking. The responsibility for overseeing this immense and perpetual task fell to the Republic's powerful Magistrato alle Acque, the magistracy of the waters. This body of engineers and administrators understood that dredging was not an emergency measure, but a routine as essential as repairing a roof or paving a street. They maintained meticulous records, charting the depths of canals, prioritizing the most critical arteries, and organizing the complex logistics of mud removal and disposal. The most thorough method of dredging, reserved for the smaller, internal canals, involved a process of complete isolation. The section of the Rio to be cleaned was sealed off at both ends. This was achieved by constructing temporary dams, known as casse. These were not monolithic structures but were carefully built from vertical wooden planks, driven deep into the soft sediment of the canal bed, edge to edge, forming a watertight barrier. The small gaps between the planks were meticulously sealed using a thick, viscous clay, itself dredged from another part of the lagoon, packed tightly by hand to prevent leakage. Once both ends of the canal section were sealed, the laborious process of dewatering began. Using simple, hand-operated Archimedean screws or bucket brigades, the water within the casa was slowly, painstakingly transferred back into the adjacent, undammed part of the canal. As the water level dropped, the canal bed was exposed to the air for the first time in decades, or even a century. What was revealed was a uniform surface of dark, odorous mud. This was the domain of the cavatori or palatori, the specialist laborers who perform the physical excavation. Working in the enclosed, damp, and often foul-smelling environment, they stood on wooden planks laid across the surface of the mud to distribute their weight and prevent themselves from sinking. Their tools were rudimentary but effective. Long-handled, square-mouthed shovels were pale, designed for scooping the wet, heavy silt. The work was rhythmic and exhausting. The shovel would be driven into the mud, lifted with a precise quantity of sediment, and deposited into a nearby wooden wheelbarrow. The structural integrity of what we now perceive as a simple canal-side walkway, the fondamenta, was, in fact, a matter of continuous and meticulous statecraft for the Venetian Republic. It represented far more than a pedestrian thoroughfare. It was the critical interface between the built environment and the water that defined it. The term itself, fondamenta, meaning foundation, is instructive. It was not an addition, but an essential component of the city's stability, a linear retaining wall that held the very soil of the islands and the buildings upon them back from the erosive embrace of the canals. Maintaining these structures was a perpetual Sisyphean task, governed by a complex interplay of material science, hydraulic engineering, and bureaucratic oversight. The forces acting upon a fondamenta were numerous and unceasing. From one side, the land, compacted with centuries of fill and bearing the immense weight of palazzi and houses, exerted a constant lateral pressure. This terrestrial force sought to push the wall outwards into the canal. From the other side, the water exerted its own pressures. The hydrostatic force of the canal's volume was a given, but it was the dynamic actions of the lagoon that posed the greater threat. The twice-daily tidal scour, the ebb and flow of water, would gradually undermine the base of the wall, carrying away the soft sediment upon which it rested. Furthermore, the wake generated by boat traffic, the phenomenon known as moto ondoso, created waves that lapped and crashed against the stonework, slowly but surely eroding the mortar and the very face of the stones themselves, particularly at the waterline, the zone of maximum stress. The very existence of Venice, therefore, depended on the resilience of these engineered banks. The process of constructing and, more importantly, repairing a fondamenta was a standardized yet highly skilled operation. It began, as all things in Venice did, below the water. Before any visible wall could be raised, a secure footing had to be established in the unstable mud of the canal bed. This was achieved through the driving of timber pilings, smaller in diameter and length than those used for major buildings, but serving a similar purpose. These were typically made of larch or oak, woods chosen for their durability in anaerobic, waterlogged conditions. They were driven in a dense, staggered pattern, often several rows deep, extending along the entire length of the planned wall. This created a subterranean palisade that served two functions. It consolidated the soft mud, giving it a degree of structural coherence, and it provided a fixed grid upon which the subsequent layers could be built, preventing lateral slippage. Between this outer row of support pilings and the bank itself, a curtain of sheet piling, or palanquille, was often driven. These were thick planks of wood with interlocking or overlapping edges, hammered side by side to form a continuous, relatively watertight barrier. This timber wall was a crucial first line of defense, preventing the soil and fill of the island from leaching out into the canal and containing the foundation materials for the wall proper. Upon this submerged forest of wood, a horizontal platform was established. This often consisted of thick larch planks laid across the tops of the piles, creating a grillage. On top of this wooden base, a thick layer of rubble and stone fragments was deposited. This material, often salvaged from demolished buildings, was known as the zatteron, or great raft. Its purpose was to evenly distribute the immense weight of the stone wall that was to be built upon it, preventing any single point from sinking into the mud below. It was a crude but effective method of creating a wide, stable footprint for the structure. Only then could the masonry work begin. The most critical part of the fondamenta was its base, the section at and just below the average water level. The slow, inexorable decline of the Venetian Republic in the late 18th century was mirrored not in dramatic collapse, but in the subtle fraying of its ancient and intricate logistical systems. For centuries, the lifeblood of the city, its very physical integrity, had been managed by the Magistrato alle, Acque, the water magistrate. This body, a testament to Venetian pragmatism, oversaw the constant Sisyphean tasks of dredging canals and reinforcing the foundations upon which the city rested. The methods were old, honed by generations of practice. The pile drivers, the Marangoni di Stanga, operated their manual Battipalo machines with a rhythmic, chant-driven efficiency, their heavy wooden rams falling with predictable thuds onto the heads of larch and oak piles. The dredgers, the cavafangi, used long-poled spoon nets and pontoon-based contraptions, scooping the accumulating silt from the canal floors in a laborious, almost geological process. The supply chains for timber from the mainland forests of the terra firma, for Istrian stone, for the very ropes and iron fittings of the machinery, were all governed by regulations and guild practices as solid and deeply set as the piles themselves. This was a system in equilibrium, a managed decay. But the turn of the 19th century would bring with it forces that this ancient system was unprepared to face, introducing new threats and, eventually, new technologies that would irrevocably alter the relationship between Venice and the water that both sustained and threatened it. The first and most profound shock was not technological, but political. The fall of the Republic in 1797 at the hands of Napoleon Bonaparte shattered the administrative framework that had supported the city's infrastructure for a millennium. The Magistrato alle Acque was dissolved, its authority fragmented, and its funding severed. The intricate web of contracts with timber suppliers, the protected status of the state forests, the hierarchical structure of the guilds, all were thrown into disarray. Under French and later Austrian rule, new administrative bodies were formed, such as the Ir Ufficio delle Pubbliche Costruzioni, the Imperial Royal Office of Public Construction. These new authorities were staffed by engineers and bureaucrats trained in a different tradition, one less reliant on inherited knowledge and more on empirical science, on surveying, on precise calculation. They brought a new perspective, but for a time, the crucial, continuous work of maintenance faltered. Canals began to silt up at an accelerated rate. Reports of subsiding foundations and decaying canal-side masonry, the riva, grew more frequent. The old equilibrium was broken. The city, for the first time in centuries, was truly vulnerable, its foundations threatened not by the sea, but by administrative chaos. It was during the long periods of Austrian administration in the 19th century that a more systematic, scientific approach to the city's problems began to take hold. The Austrians, with their penchant for order and engineering, conducted the first truly comprehensive hydrographic surveys of the lagoon and the city's canal network. They mapped the depths, charted the currents, and analyzed the composition of the silt. This data-driven approach revealed the scale of the problem, but it also coincided with the arrival of a new, transformative threat, the steamship. The first paddle steamers and, later, propeller-driven vessels were larger and heavier than the sailing ships and oar-powered craft of the Republic. Their passage through the canals generated a more powerful and destructive wake, a phenomenon the Venetians would come to call moto ondoso. This constant wave action relentlessly eroded the mortar between the bricks and stones of the canal walls and lapped aggressively at the foundations of the palazzi. The visible city of Venice, a tapestry of stone and light, is but a fraction of its whole. Below the shimmering surface of the canals, beneath the dark reflective waters, lies its true genesis. This is the realm of the foundation, a submerged forest of timber upon which the impossible city was built. To understand Venice is to understand this hidden architecture, a legacy of pragmatic engineering that has endured for centuries. This chapter is concerned with the act of looking back, of surveying these ancient foundations. It is a process devoid of fanfare, a quiet and methodical science that takes place in the silt and the shadows. The surveying of submerged Venetian foundations presents a unique set of challenges, distinct from terrestrial archaeology. The primary obstacle is, of course, the water itself. The lagoon's water is not clear. It is a brackish, turbid medium, clouded with suspended sediment stirred by the tides, by the passage of vaporetti, and by the natural processes of a complex estuarine environment. Visibility, even on the calmest of days, is often limited to a meter or less. This aquatic veil obscures the very objects of study, transforming direct visual inspection from a primary method into a challenging, highly localized endeavor. Furthermore, the foundations are not clean and exposed. Over the centuries, a thick layer of sediment, a composite of organic matter, silt, and urban detritus, has accumulated on the canal beds, burying the lower sections of the piles and the raft foundations they support. To survey the legacy below is therefore an act of peering through murk and penetrating through layers of accumulated time. Historically, the Venetian Republic's own engineers, the Magistrato alle, or water magistrate, were acutely aware of the need for constant vigilance. Their methods were direct, tactile, and reliant on profound experiential knowledge. One of the principal tools was the sounding rod, a long, slender pole of hardened wood or iron. An experienced inspector, known as a sonda, would stand on a small, stable barge, a piada, and systematically probe the canal bed around the foundation of a palazzo or a bridge. This was not a simple act of measurement. The inspector was listening with his hands. The feedback transmitted up the length of the rod was a language he was trained to interpret. A sharp, solid report indicated sound Istrian stone or the dense, intact heartwood of an oak pile. A dull, soft thud, a muted absorption of the impact, could signal decaying timber, a pocket of sediment where a pile should be, or the compromised integrity of the foundation raft. The angle of the rod, the way it skittered or settled, all contributed to a mental map of the unseen landscape below. For a closer, albeit limited, visual inspection, a device known as a specula was sometimes employed. This was a simple but effective tool. A long tube, often made of wood or metal, with a watertight glass plate at its lower end. When pressed just below the water surface, it broke the surface tension and reduced the refraction and reflection of light, allowing the viewer to peer more clearly into the depths. Paired with the low, raking light of early morning or late afternoon, the specula could reveal the upper portions of the piles, showing the telltale signs of marine borers or the erosion of the protective stone capping. It was a small window into the submerged world, demanding patience and an understanding of the subtle interplay of light and water. Modern surveying techniques have, of course, augmented these traditional methods with a suite of technologies that render the invisible visible. The process often begins with a non-invasive acoustic survey. A survey vessel, moving at a slow, constant speed, employs a side-scan sonar system. This device emits fan-shaped pulses of sound waves or pings that travel outwards and downwards from the vessel. We arrive at last at the culmination of our journey. We have traversed the dense, managed forests of the terra firma, followed the slow, deliberate journey of timber down the Piave and the Brenta, and stood witness to the relentless, percussive effort that drove millions of wooden piles into the soft underbelly of the lagoon. We have examined the meticulous, unending cycle of dredging and maintenance that keeps the city's aqueous arteries from silting into stillness. Now we must draw these threads together to gaze upon the complete tapestry of Venice, not merely as a marvel of architecture and art, but as a profound, enduring monument to human ingenuity. The story of Venice is, in its most fundamental sense, a story of negotiation. It is a dialogue conducted over centuries between human ambition and an uncompromising natural environment. The first settlers, seeking refuge in the salt marshes, did not conquer the lagoon. They did not drain it, nor did they seek to wholly tame it. Instead, they listened. They observed the subtle language of the tides, the patterns of sediment deposition, the unique properties of the saline mud. From this deep, empirical understanding, an extraordinary solution was born. A solution that was not imposed upon the environment, but rather integrated within it. The pile foundations, the very bedrock of our study, exemplify this principle. The choice of wood, larch and alder for their water-resistant qualities, oak for its strength, was not accidental. It was the product of generations of trial and error. The method of driving them, closely packed, deep into the mud until they met the layer of compressed clay and sand, known as the coranto, was a precise science learned through practice. The true genius, however, lay in understanding the subaqueous chemistry of the lagoon itself. The founders of Venice recognized, perhaps initially by happenstance and later by design, that the anaerobic, mineral-rich mud would not cause the wood to rot. Instead, it initiated a process of petrification. Over time, submerged in this oxygen-deprived environment, the wood absorbed minerals, hardening to a stone-like consistency. The piles did not simply support the city, they became a part of the lagoon's geology, a man-made forest, inverted and fossilized, upon which a metropolis of marble could rest. The scale of this undertaking remains difficult for the modern mind to fully comprehend. We speak not of thousands or even hundreds of thousands of piles, we speak of millions. The foundations for the Santa Maria della Salute Church alone required over 1 million timber piles. For the Rialto Bridge, tens of thousands were driven into the bed of the Grand Canal. Every palazzo, every church, every modest dwelling rests upon this hidden, subterranean woodland. This was not the work of a single generation, but a continuous, state-sponsored effort that spanned the life of the Republic. It was a foundational act, repeated ad infinitum, woven into the very fabric of Venetian civil engineering. This colossal demand for timber necessitated another form of ingenuity, logistical and bureaucratic. The Venetian Republic could not afford to leave the supply of its most critical resource to chance. The state, through institutions like the Council of Ten and the Arsenale, extended its control deep into the mainland territories. They established vast, protected state forests, such as the Bosco del Consiglio, specifically designated for supplying the city's foundational and maritime needs. An entire corps of forestry officials managed these woodlands with a long-term perspective that is, in itself, remarkable. They understood ecological cycles, rotation periods, and sustainable yields. They were not merely exploiting a resource, they were cultivating it for a future they knew would depend on it. The transportation of this timber was a masterpiece of hydraulic logistics. And so, Venice sleeps. The canals fall silent, reflecting only starlight on their dark surfaces. The city rests, secure on the ancient forest driven deep into the lagoon floor. Thank you for joining us on the Whispered Lore. As the gentle tide laps against the stone, let it be a lullaby. Allow the quiet strength of these foundations to cradle you as you drift into your own deep and peaceful slumber. Good night. Rest well.